Okay, we're back in the workshop, and I have this server rack battery, and this cell right here lost its inside bits and came out the vent and sort of oozed all down the back here and sort of ate the paint off of the inside here. And it swelled up really, really, really big. So it was like a half-inch bigger than it had previously been. So I don't know what this BMS is doing. So I called the manufacturer and they sent me a new battery, which was nice. But I really didn't want to like put this in my trash can or something like that. So I took it apart. I pulled out these screws here and tipped it on its side and slid this entire pack of cells out by disconnecting some wires that you could imagine. And I took out the offending cell and then the adjacent cell. And I spent some time trying to sort of look on the internet to find a replacement cell, but I really had a hard time finding all of the characteristics of these all together at once. So I found a lot of cells with studs, but not threaded holes. And I found a lot of like 310 amp hour cells, which were like huge. These are all like, I guess I have no idea what they are. I'm assuming they're 105 or 100 or 105 amp hours or something like that. This is a 48 volt configuration in 16S. So, and the other thing is the dimensions had to be exactly the same as these. I don't think I could take a millimeter different. So I used Google Lens, and that was unuseful. And then I found a photo of a cell that appeared to be similar to this. I think maybe it's a CALB cell. I'm not really sure. There's a absolutely inscrutable. Oh, look, it says it's 100 amp hours. See, there you go. There's some data. Yeah. I don't know who made it, but I happen to have this battery, which looks like hell on the outside it was involved in a thermal event. But this battery was just adjacent. And I pulled out 2 cells out of it because they're the same exact cells. So, yeah, and then I sort of sanded I really did sand the back of it really good, but not so much the top. I kind of give up. Whatever's in these cells sort of corrodes everything and kind of dissolves the paint wherever it sits. But now I'm trying to get it going here, and it looks like it stopped charging, which is cool. It's showing 55, and I'm showing backwards polarity, 55.2, I think is what it said. So 55.11, it's really close. But it's still giving me the alarm, and it's also still showing a state of charge is low, so maybe it needs a reset. Maybe it needs a welding rod here. never know what to do with this. Hold it till it resets. It's going to shut down now. Is that what it's going to do? Shutting down. Okay. Maybe this is the reset. Huh. I would have thought that the state of charge was based on the voltage, not its history of charging. So I charged it and it went from 0 state of charge to 0.7, and then either it shut off the charge or my charger shut off the charge. But I think the charger shut off. No, I think the battery shut off the charge because the charger's blinking yellow. So I don't know what to do with this thing. Well, that's anticlimactic. One push. One push doesn't do anything. Push and hold. This is what I just did. Well, that's not exciting. Well, I guess that's all I got. This UI is not very informative about what its problem is. I'm sure that this alarm is just for a low state of charge. Yeah. Well, that's exciting. Well, all the cells seem to be matched now, and there doesn't seem to be a big discrepancy in voltage between any cells, and they're all there and showing good voltage, and it charged a little bit. So, I don't know. I wonder if there's a better way to reset the BMS. Oh, good. That definitely runs the BMS. BMS is off now. Cool. Maybe that's a better reset. The connector is so hard to put together. I wonder why it needs to be taped. Oh, look. Check that out. It says full SOC. That's cool. That's different. So it's still not charging because I think it's charged. And the capacity is 79.99. Well, that's way better than 0.7. I'll probably have to discharge this and then recharge it to reset that capacity meter, because I think that the BMS meters the in and out and then calculates that. So it's cool. It's still giving me the run light, although it doesn't show any current flowing. Yeah, this RM, is that remaining capacity? I don't know. Usually that just says like 100. Okay, well, that's the whole video. I would say this thing is looking pretty good, and I think I should hook it up to an inverter and discharge it and then recharge it, and then try and see if got this inverter here. So I'll drag this one out. This one has a set of cams on it that I can plug into, which is really cool. So I'll drag this one out and set up the interface and then discharge that battery and see how that goes. Anyway, well, thanks for looking. Sorry the workshop's a mess, but this is how my life is now. Okay. Bye-bye. Okay, I'm back. We got the inverter hooked up, and we're drawing 36 amps. And like before, the capacity is still showing sort of 70 something. So it's flowing 36 amps, which looks good. And we got it hooked up temporary style to this Radian. So this is a 8048, I think. Yeah. And it's got a 6-gauge output, and I temped it on real quick here. Not optimum, but and then this is just a little thing I can plug a thing into. So Radian is running. This has DINS 50 connectors on it, so I can drop some type W cable and hook it up in a remote location, and I have some 2x0 DINS 50 cable that we use for that, but I put a little Anderson connector on the end here and made a little whip to hook it up to the little battery here. I'm going to try and run that one down. So I'm running a heat gun. So the heat gun is just tied into that little box. So I'm going to run this down for a little bit, and then when I get close, I'm going to switch to actually just running it with lights, so that the voltage sag of the batteries doesn't cut it off early. And the inverter is programmed to shut down at 44 volts or something. So the low voltage protection of this will kick in way before that. So like I said, I'm going to run it on the heat gun for a little while, and then once this gets down to 15%, I'm going to switch over to just running a little string of LED lights overnight, and I want to kill it at a low load. And then tomorrow morning, I'll come back and revive it. So what I'll do is I'll use this Anderson connector here and hook up the charger, and then the charger won't start. It's a funny thing about lithium batteries. So this charger won't start until the battery is outputting or has voltage on the terminals. and then this will start charging it. So what I have to do is I have this 48 volt power supply here, and it outputs enough voltage to jumpstart this whole operation. So what I'll do is once this battery sees voltage on the terminals with this temporary, it'll open the MOSFETs, and then I'll be able to turn this on, and then it'll start charging it. This won't try and charge this because this voltage is really low, only 48 here. And this is trying to output like 56. So this won't try and charge this. But if this sees voltage, it'll start charging. So anyway, I use a power supply because the power supply outputs voltage no matter what. It doesn't care if there's a battery connected or not. And then the other thing I did with this today was before I turned this circuit breaker on, what happens with this inverter is the big capacitors in it will make this think it's a short circuit. So this will shut off. So what I do is I turn off the breaker, I connect the 48 volt power supply to these terminals here, or any terminals, and then I start the inverter. And once the inverter is running with no load on it, then I turn the circuit breaker on and take away the power supply. And that way, this power supply will charge those capacitors before I bring the battery into the circuit, which will stop the battery from alarming for overcurrent or short circuit. So anyway, I'm going to run this down, and maybe I'll add on to this video again. Thanks. Okay. It looks like this is about the end of the battery story. So I ran this inverter down to the battery disconnect voltage, and I ran it with a string of Christmas lights so that I would drain the battery as low as possible without having like the voltage sag cut it off before it's totally dead. And then I disconnected the inverter here, and I hooked up the charger, and I jumped the battery with this power supply, like I said, to get it to wake up. And the charger charged it overnight, and so it charged up, and it looks like it's got over 100 amp hours of capacity. So what happened is as like it went down to low voltage disconnect, and then as the charger charged it overnight, the BMS inside monitored how much energy passed through it, and then it shut off for high voltage disconnect, or the charger shut off. I don't know which way it is, but maybe the charger shut off because it's actually saying 99.64 instead of 100. But I think if I got it up the rest of the way, it might actually be 104. We haven't really used these batteries, like they're not deteriorating from cycling. But yeah, so I guess that's the end of the battery story. Yes, user serviceable. Check. I'm pretty happy about that. Like I said, I wasn't able to find the cells, and I had to scavenge some cells that I had, but that worked out fine. I'm happy about that. I bought a replacement one of these from SOK for $300. So I'll have a set of 4 again because I'm using them in series. So, but yeah, that's the whole story. Cleaned up the workshop a little bit. Got the welding table looking nice. Got the cooler off the floor into the hole. And then still have the heater. And then the little power distro inside here is wedged in there. And then the plasma cutter and the little MIG welder are just chilling in their normal spots. So, on to another project. Thanks for looking.